Hello again, welcome to lesson 8. We're going to go over the thinking question before we move on to a very different topic. So how is the long division algorithm related to the partial quotient strategy? It's related because we're still creating partial quotients, we're just not doing it and showing all of the numbers at the same time. So in the partial quotient strategy, you list them all down in a column, but in the traditional algorithm, you're just doing it piece by piece and you're pushing it all together before that last step. So like I said, we're switching gears today and we're moving into equivalent fractions. There's going to be a lot of new ideas in this lesson, and I'm really going to encourage you to try and follow along and try to understand it as best you can. You're going to need your paper and pencil as usual today and nothing else. So, something that's really important to understand about fractions, just like with decimals, the one isn't always the same. So we can have a fraction be a fraction of a whole piece of pizza, or I can cut up this small piece of pizza into a bunch of different pieces. Although those aren't all even. I could make it so that they are even, and then that would be a fraction. So that's important to note. The one is not always the same. The whole's not always the same. The whole can also be a classroom of students, or it could be a whole school of students. It could be an entire chocolate bar, or it could be just one of the little squares of a chocolate bar. The whole can be virtually anything that you can imagine. As long as it can be cut up into smaller pieces and into fractions, then that can be a whole. The next thing that you need to understand is that the whole can be broken up into as many or as few pieces as you want. So this pizza doesn't have to be broken up into the 8 pieces that it's broken up into. I could break it into 100 pieces if I wanted. I'm not going to, because those would be really small pieces of pizza, but you could do that. You could take that same pizza and cut it into 2 pieces. Or you could cut it into 6 pieces. The whole can be cut into as many pieces or as few pieces as you want. However, when you decide to cut something into more or less pieces, that's going to change the size of the piece, obviously. So if you have 8 slices of pizza in this whole pizza, the pieces are going to be bigger than if you had 100 pieces. If I were to cut those into 100 pieces, those pieces would be tiny. But if I only cut it into 2 pieces, those pieces are going to be a lot bigger than if I had 8 pieces. So depending on what fraction you cut it into, how many pieces you cut it into, the pieces are going to be different sizes. Now let's go over the parts of the fraction in case you don't remember from school. So a numerator is the top number that tells you how many pieces out of the whole or one that you have. So it's the top number of the fraction. So here's our fraction. It's going to be the number up here. That looks like a 0, so we're going to put a number in there. Let's say 8. So 8 is our numerator. That's telling me I have 8 pieces out of the whole. But I don't know how many pieces there are in all of the whole. That's what the denominator tells us. The denominator tells us how many pieces are in the whole all together. So if you had all of it, this is how many pieces you would have. It's the bottom number right down here. So let's say there's 10 pieces in the whole. So let's just go back to the pizza example. The pizza is cut into 10 pieces and 8 of them have pepperoni. So 8 out of 10 pieces have pepperoni. The other 2 don't. So that's the numerator and the denominator. If at any point in this video you forget what either of those mean, just rewind to this point and remind yourself. So let's say that you are going to be having a party and you order a pizza, and that pizza comes with 8 slices. It's already cut into 8 slices. So here are my 8 equal slices. Everybody's going to get the same size slice. The pizza's cut into 8 pieces. But then more guests show up than I'm anticipating. So I decide to cut each piece in half. So now each piece is 2 pieces. counting these now, I have 16 pieces. Well, let's say one of my friends takes 2 of those pieces. They took 2/16, 2 out of the 16. But if we also look carefully, 1/8 is the same as 1/16. Those 2 fractions are equal. That means they're equivalent. That's a word that we use in math to say that things are equal. They're equivalent. They're the same. They say the same thing, but they have a different name. This is saying 2 pieces out of 16, and this is saying 1 piece out of 8, but they're the same. So why is it important to know that these 2 fractions are equivalent? Well, it's hard to see now, but in a couple of lessons you'll find out. When you're adding and subtracting fractions in particular, this is really important. You have to be able to find equivalent fractions. So now that we have a little bit of an idea of what an equivalent fraction is, we're going to work through it and figure out how we find equivalent fractions, and also work on understanding what they are a little bit more. So let's look at another example of equivalent fractions. So circle is cut into 3 pieces, and let's say my fraction is going to be 2 of those pieces, so 2/3. So I'll write that over here, 2/3. Now, I'm going to break each of these pieces into more pieces. But I have to break each of them into the same number of pieces, because otherwise I'm going to totally mix up the sizes of the pieces. Because if I break 1/3 into 5 pieces, let's just show you for example. 1, 2, 3, 4, 5. Those aren't quite even, but we will make do. And I break this one into 2 pieces. That's a completely different fractional part than this piece, because that's larger than this one. They have to be the same size. It has to be out of the same number of pieces. So, color that in again. Forget. We have 2/3. Now I'm going to break each one into 4. Are about even, and I'm going to break this one into 4 as well. So now this whole circle is broken into 12 pieces if you count them all. 12 pieces. How many are colored in? 1, 2, 3, 4, 5, 6, 7, 8. 8. The same amount of the circle is colored. 8/12 represents how much is colored. 2/3 also represents how much is colored. It's just sharing a different number of pieces, but the pieces in the end are the same size. It's just how many pieces it's broken up into. But as you noticed, the denominator changed, so did the numerator. Because if I said, okay, it's out of 12 now, okay, 2/12. That would only be this. That's not the same as what I colored. So you have to change both the numerator and the denominator to make equivalent fractions. And I'll teach you how to change those. Now, something you may have noticed, you may not have. I'm going to actually erase this so we don't get confused, since that's not an equivalent fraction. Something you may have noticed is that 3 times 4 equals 12. We split each third into 4 pieces, so that's now 3 groups of 4 that we made, technically. So now we have 12 pieces. Well, 2 times 4 also equals 8. So if you multiply the numerator and the denominator by the same number, you're going to find an equivalent fraction. Because that's saying, okay, we had 2 pieces. Now if I split those 2 pieces into 4, just like I split the 3 pieces into 4, then I'm going to be able to find how many pieces are colored in. Okay, so let's practice finding an equivalent fraction for this circle. So we have 5 pieces altogether, and 4 of them are shaded in. These are the ones that are shaded in. So that fraction is going to be 4/5. Now, let's say I split each one into 3 pieces. So if I did that, so now each section is split into 3 more pieces. So how many pieces is it out of now? Pause the video and find out. It's out of 15. And we could figure that out by 5 times 3 because I had 5 groups and I split each group into 3. So that's going to equal 15. And then I had 4 sections that I also split into 3 because I split them into the same number. So if I do 4 times 3, that's going to be 12. So my equivalent fraction is 12/15. It's really interesting, isn't it? Try finding an equivalent fraction for 1/6 on your own. Pause the video and do that now. So we had 1/6 shaded in, and I chose to split each 6th into 2 pieces, which means that I would multiply each of these by 2, and I got 2 12ths. However, you could also have gotten 3/18ths or 4/24ths. You could also keep going. There's a lot of possibilities, but those are ones that you probably chose to do. All right, you're going to find 2 equivalent fractions for this circle now. So it looks like we have 1, 2, 3, 4, 5, 6, 7 total pieces, and 5 of those are shaded in. So find 2 equivalent fractions for this representation. Here are a bunch of equivalent fractions. You could have said 10/14ths, 15/21, and 20/28. You would just have to multiply both the numerator and the denominator by the same number, and that would get you your equivalent fractions. We can also go from a smaller to a larger fraction. I say smaller to larger because when the denominator is larger, that actually means we have a smaller piece. And when we have a larger or smaller denominator, that actually means we have a larger piece. Because if you only have a denominator of 2, that means it's only split into 2 pieces. Those are big pieces. But if you have a denominator of 20, it's going to be split up into 20 pieces, and that's going to be really small pieces. So we can also go from smaller to larger fractions. So here we have a circle with 16 pieces, and let's say I shade in 12 of them. All right, so here's 12. Now you can't see all the circle because it's so big, but here's 12. I'm just gonna kind of scribble it so you get the idea. There's 12 of those pieces, okay? So we can easily see the distinction. Now we can break this into a smaller number of pieces. Let's say I want to break it into, let's say I want to break it into 2 pieces, the whole circle. So the 2 pieces have to be even. They have to have the same number of these pieces on each side. So that would look like that. Well, that's not going to work because here I have 12/16ths. Well, I can't make it an equivalent fraction when I have just 2 pieces because this doesn't represent a whole piece and that doesn't work. So what if I try splitting it into 3 pieces? So if I have 16 pieces, well, that's not going to work either because there would be 1 piece left over, and that doesn't work because there'd have to be 5 pieces in each larger piece. What about 4 pieces? Let's see. If I have 16 smaller pieces and I want to break into 4 larger pieces, that would mean that I can put 4 little guys in each big guy. Look, those are even, and that works because look, the green exactly fills up the 3 sections. So an equivalent fraction to 12/16ths is 3/4, which, if you'll notice, 12 divided by 4 equals 3, and 16 divided by 4 equals 4. So you can both multiply and divide the numerator by the same number and get an equivalent fraction. So if you have a number with a large denominator, absolutely divide if you can. Let's see if I can make any more equivalent fractions by dividing this into larger pieces. So I'm going to erase these red lines just so we don't get confused. What if I split it into 5 pieces? Nope, that won't work because 5 doesn't go into 16 evenly. 6 pieces? No. 7? No. 8? That'll work. I can divide 16 pieces into 8 smaller pieces evenly. I just have to put 2 in each one. Okay, so there's 2 smaller pieces in each larger piece. So how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 are shaded. And then of the larger pieces, we have 1, 2, 3, 4, 5, 6. So 6 out of 8, 6 eighths is another equivalent fraction. So 12 sixteenths is equivalent to 6 eighths. And we can divide that. 12 divided by 2 equals 6. And 16 divided by 2 equals 8, 6 eighths. Now we can't go and break it down any further because if we do, then it's going to be only 1 piece per, and then that'll be back to our original equation, or our original fraction. So our equivalent fractions are 12 sixteenths, 3 fourths, and 6 eighths. Those are all the same representation in this circle. All right, that was a lot of numbers, a lot of fractions all at once, but I want you to notice how I asked myself frequently, how many times does this number go into the denominator? If it went in evenly, then I knew that I would be able to break this up in such a way that there would be the same number of pieces in each larger piece. And so that helped me to find an equivalent fraction. And that's something that you can ask yourself so that you don't take too much time solving that. I'll walk you through finding one more of these and then you'll do a couple on your own. So this fraction circle shows, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10. So 8 tenths is our fraction. And we're going to find an equivalent fraction that's made of larger pieces. So I'll ask myself, can I make it into 2 pieces? Well, 8 does go, or 2 does go evenly into 10, but if I split it in half, the yellow has to completely fill one or the other, or both. It doesn't. It doesn't completely fill the one section, so that won't work. What about 3 pieces? 3 doesn't go evenly into 10, so I won't be able to split that evenly. 4 pieces also doesn't go into 10. 5 pieces, that does go into 10. So there's going to be 2 in each section. Stay there. So now we have a total of 5 pieces. So that's going to be our denominator. And there are 1, 2, 3, 4 shaded in. So 4/5 is equivalent to 8 tenths. And I can divide that, I see, by 2. And that will give me my answer. Can I divide it into 6 pieces? Nope. And not 7 pieces? Nope. If I divide it into 8, 9, or 10? No. It would be the same if I divided it into 10 pieces, so that's not going to work. Okay, so for this one, you're going to, on your own, try and find a reduced equivalent fraction. What I mean by reduced is that you're going to make the denominator smaller. So you're going to break it up into fewer pieces. Pause the video and do that now. So hopefully you found that 6/9 is equivalent to 2/3. And you can find that either by drawing it out or you can divide each one by 3 because they're both divisible by 3 and you'll find that you get 2/3. Let's try another one on your own. You're going to find an equivalent fraction, 2 equivalent fractions in fact, both reduced for this representation of a fraction. Pause the video and do that now. The 2 equivalent fractions are 3/6 and 1/2, because if you divide 6 by 2 and 12 by 2, once that shows up, there we go, it's going to get you 3/6, and if you divide 6 by 6 and 12 by 6, you're going to get 1/2. So those are both equivalent fractions. I'm going to try a challenge now. I'm going to put 2 fractions on the board, and you're going to try and find an equivalent fraction for both of them, but they both have to have the same denominator. So this fraction, you need to find an equivalent fraction for. So 3/5 needs to be equivalent to 3/5, and a fraction that's equivalent to 1/10, but they both have to have the same denominator. Pause the video and try and do that now. All right, so you didn't actually have to find an equivalent fraction for 1/10 because you could make 3/5 into 6/10. And the way we did that was we multiplied 3 times 2 and 5 times 2, and we got 6/10. Now, if you did find an equivalent fraction for both, so if you did change that fraction, you also could have gotten 12/20 and 2/20. This is going to be an important skill to have when we're adding and subtracting fractions. You have to make two fractions have the same denominator. Here's another one I'd like you to try. You're going to have to work a little bit harder to find the equivalent fractions where they both have the same denominator. Pause the video and do that now. So the answer is 4/12 and 9/12. And the way I found that was I multiplied the numerator and the denominator each by 4, and that equaled 4/12. And then over here, I multiplied each of them by 3. Now what you may have noticed is that I multiplied each fraction, both the numerator and the denominator, by the same number that was in the denominator of the opposite fraction. So I multiplied each of these by 4 because 4 was my denominator, and I multiplied each of these by 3 because 3 was my denominator, and that automatically gets me the same denominator, and then it changes the numerator accordingly. This skill will really help you when we get to the adding and subtracting fractions lesson. It's okay if you aren't perfect at it yet, but we will continue to work on it. And the thinking question for this lesson is, if you had to explain what equivalent fractions are to an alien who has never heard of them before, what would you say? So think about that. How would you explain equivalent fractions to an alien? And you'll hear what I would say at the beginning of the next lesson. Goodbye.